Where are the other students, Pooja? Pooja? Pooja, are you there?
No, ma'am.
Okay. What happened? Due to weather? Not able to join? Hmm? Okay, let us wait for more 2-3 minutes. Then we will start. Shalini, Pooja, Ayushi, and Tanisha. Only 5 students are there. Only 4 students are there. Am I audible to everyone? Hello? Okay. Okay, in the last class, what I discussed with you, standard deviation and all, right? So I have completed that part. And today I will start with bridge circuit. Okay. So I'm sharing my screen with you. Okay. Is it visible to everyone? Bridge circuit? I hope it is visible. Okay, I'm having some problem in LMS portal. So at the end of my class, please do take the screenshot and send it to me, whoever are present. Maybe it's Shalini, maybe it's Pooja. Okay. Are you facing issues with LMS or I am facing? LMS में problem हो रहा है तुम लोगों को भी?
Ma'am, maybe it's fine today.
It's not fine for me. I don't know why. I tried actually to give attendance through LMS portal, but I couldn't. Let me see once, wait, if I could. Yeah, now I could. Wait for a while. Now it's okay. Wait for 2 minutes. Okay, Sito, I will be sharing the QR code with you, whether you could give it or not. Tell me. Able to see the QR code? Scan the attendance.
Yes, ma'am.
Done now? Okay. Okay, then give the attendance QR code. Okay, then we will start. Okay, 9 no, including me, 9, it's 8 participants, then we can start. Done, QR code attendance, then I'm sharing my screen. We are getting late. Last May, फिर से I will give you. Okay, don't worry. Okay, so I was discussing with you about this now today. Till now we have discussed what those limiting errors, absolute errors, gross errors, system errors. Okay, and in my previous class I think I have discussed with you about the standard deviation, the variance, and average mean value, arithmetic mean. So, and I have also given some problems to discuss with you. Okay, so those part we are done. That is in the module 1. You will find that part in the first half. Okay, and second half is all about the bridges. If you follow your syllabus, then in the second half it is about, first of all, they are not written separately bridges, but they have started with Wheatstone bridge. Okay, but you can't start that directly. First of all, you have to know actually that what is a bridge circuit? See, in instrument and measurement, okay, this instrumentation and measurement subject, you know, this bridge is a very important topic. Okay, and under bridge, so we classify bridge into two bridges. That is, one is DC bridge, one is AC bridge. Okay, so let us start with the bridge circuit. If you follow your syllabus, you will see that under bridge, the first component of first device written is Wheatstone bridge. Okay, so first of all, let us have a clear-cut idea that what a bridge. Okay, so bridge are used to measure the value of electronic components. So this thing keep in your mind, bridge are used to measure, this bridge circuit is used to measure the values of electronic components. Suppose if I take an example of Wheatstone bridge, then Wheatstone bridge is used to measure the unknown resistance of a resistor. Okay, so Wheatstone bridge has the capability to measure the unknown resistance of a resistor. Likewise, Kelvin measure some other parameters, Maxwell bridge measure some other parameters. So likewise, we can understand. So you see here, under DC bridge, if I say example, Wheatstone bridge actually measures the unknown resistance of a resistor. Okay, like Kelvin also measure the low resistance. Likewise, okay, so different bridges have different parameters to measure. So this bridge is very useful to measure the unknown value of resistance, especially if you come to DC bridge. And moreover, if we particularly come to bridges, then you can say that bridges are often used for precision measurement of component value. Okay, so precision word is very important here in case of bridges. Precision. Okay, so this what we have discussed already, accuracy, precision. So precise value, if we need to measure, we need some bridges. Like, so what are the precise value we need to measure? Like resistance, inductance, capacitance, all these things. Okay, so if I try to tell you the simplest form of a bridge circuit, that, you know, every bridge you will see, starting from Wheatstone to Wien bridge, whatever component they measure, but the structure is more or less same. They are having 4 arms, okay? But in some bridges, you may have capacitor, in some you may have resistance, but the basic structure of the bridge is same. Suppose if I draw here the basic structure, that is, you can say the simplest form of bridge circuit consists of a network of 4 resistance arms forming a closed circuit. Suppose if I draw here that kind of normal bridge circuit way, suppose it will be having a normal source. Source means the supply, that is plus minus. Then it will be just like this. And here you will be having some impedance or whatever, the basic structure I'm drawing. Okay. This is the basic structure. Here there will be a detector D. Here detector D. Okay, I'm not able to write that much. And here, this side, you will be having another impedance. Okay. So you are also having a detector D here that is connected to both the side of the impedance. Okay. And this is the point A. This is, you can say, point B. And this is, you can say, point C. And this is, you can say, point D. Okay. And this is the source V I'm writing. And this is obviously, you can tell Z1. And this component is Z2. Okay. This component is Z3. And this component is Z4. Okay. These are the four arms, or you can say general form of a bridge. And here you will see current is flowing, that is I1. Okay, I1. Then comes I2 from here, I2, like this. Then through this arm, obviously I3 will flow. Okay, and through this arm, I4 will be flowing. So this is the basic structure of a bridge. Okay, not Wheatstone or something else. Basic structure of bridge. That means how a bridge look like. That means you can see here, a source of current is applied to the two opposite junctions, and the current detector is used or connected here to the other two junctions, right? So here the source V is given here, and this is the current detector, okay, that is connected to the other two junctions. The bridge circuit that is operates on null detection principle. So you have learned also the basics of Wheatstone bridge. So better you know that the bridge circuit always work on null detection principle and uses the principle of comparison measurement methods. Okay. Now it compares what it does, how it actually proceeds, how it works. It compares the value of an unknown component with that of an accurately known standard component. So what are the how we actually measure it? We measure it with the, what is the comparison? The comparison comes with one unknown component with one standard known component. So this is the method of comparison. So thus what happens, the accuracy of measurement depends on the bridge, okay, and not on the null detector. So don't think that the accuracy depends upon the null detection. It actually depends upon the bridge. So when no current actually flow through the null detector, that is this detector which I have drawn in this picture, then what will happen? The bridge is said to be balanced. So when no current actually passes through this detector, what we say that the bridge is in balanced condition. Okay. So relationship between the component values of the four arms of the bridge at a balancing is called balancing condition. Okay, so if you're asked that in a bridge circuit, what is the balancing condition, then you can say that the relationship between the component values of the four arms of the bridge is the balancing, or you can say it's called the balancing condition or the balancing equation. Now, balancing equation definitely give up the value of the unknown component, because we use bridges to find out the unknown value, okay? And that can be compared with the known standard value. Okay, understood this much portion, that why we need a bridge circuit? Why we need a bridge circuit? Hello? Hello? Is any, hello? Am I audible?
Yes, ma'am.
Okay, okay. Let me know, okay, because I'm not sure, because the weather is bad and it's difficult for me to understand. So this is the main structure, basic structure of the bridge, as I told you, and why we use bridge circuit. Now, there are various advantages of bridge circuit. Out of that, you keep in mind that the balance equation is independent of the source voltage magnitude and this impedance. So whatever equation we can get in any of the bridge circuit, Steering, Wien, Owens, Hay, Maxwell, whatever. Okay, here you can get a balanced equation that is independent of the source voltage magnitude and this impedance. Okay, so these are the important points which you should remember before studying bridge circuit. Now slowly we will move on to the Wheatstone bridge. Now, another thing, let me tell you before moving, as I told you that Wheatstone bridge we use for measurement of unknown resistance of a resistor. Now, bridge circuits can also be used for precision measurement, as I told you in some of the circuit, and also for interfacing of transducers. Actually, you can say nowadays fully automatic bridges will which actually electronically null a bridge to make precision measurements are mainly used. Okay, so you can say fully automatic bridges which electronically actually null a bridge that is used for precision measurement. Okay, so I'm clearing this part. Now you can see here a definition is written in this particular slide that a bridge circuit is a null method which is operates on the principle of comparison, and that is known standard value is adjusted until it is equal to known value. So we need to find this known value with the help of the bridge circuit. Now you come here, bridge circuit. Bridge circuit, you see bridge circuit are of two, classified into two parts. One is DC bridge, one is AC bridge. So DC bridge here, we only try to measure resistance, maybe high, maybe low, maybe medium, whatever, but we measure resistance. So the examples of DC bridges are Wheatstone bridge, Kelvin bridge, mega ohm bridge. Okay. I hope if you check out your syllabus, you have only Wheatstone and Kelvin. Mega ohm is extra. So let us see what we do. And in case of AC bridges, so in AC bridges, we actually try to measure inductance, capacitance, frequency. Okay, both the three things. And so under inductance, we try to measure the examples of inductance bridge are Maxwell, Hay, Owen. Okay, so these are important bridges to measure inductance. So don't get mixed up. Sometimes it happens that we get confused that which bridge measures what. So for inductance measurement, we require three bridges, that is Maxwell, Hay, and Wien. Don't mix up again with Owen and Wien bridge, both are totally different. And then capacitance measurement, we need sharing bridge. Okay, so only one bridge you have for measurement of capacitance. And the last is for the frequency measurement, you have Wien bridge. Okay, so this is very, very important to know that DC bridges, what they measure and what are the name of the DC bridges, AC bridges, what they measure and what are the name of the AC bridges. Okay, so only then we can study all those bridges. So first of all, in your syllabus, if you see, you will find the first bridge is the Wheatstone bridge. So come here, let us see the Wheatstone bridge. So I hope this slide is visible to you all, and a very clear picture of a Wheatstone bridge has been shown here. Okay, so Wheatstone bridge has some features, some characters, and the picture I told you that in case of bridge, you will be having those four arms, very common. Okay, and current will be flowing through all those four arms. Okay, you will be having a detector in the middle, and you in some bridges you will be having resistance to measure, in some bridges capacitor, some bridges inductance, that will vary accordingly. Now, as in Wheatstone bridge, we are measuring what resistance, right? We need to measure the resistance or the unknown resistance. Means what happens in Wheatstone bridge, if the four resistance are denoted, and if any one resistance value you don't know and other three you know, you can easily find out the resistance of the fourth resistance. Okay, the specific formula is there, and you know current is flowing, detector is there, so everything. And one more thing, that your galvanometer is also used. Okay, in balance condition, galvanometer, I think you have learned in physics also that how it works. So some portion of that we will also see here in this Wheatstone bridge. So see here in the Wheatstone bridge, I think you can see your supply is given just like the basic diagram I have shown you. A detector is shown here, four resistance are given, R1, R2, R3, R4. And 4 points are there, A, B, C, D. You can say poles, and here is a detector, which will detect that what is the resistance, how much current is flowing, everything. Okay, now there's the circuit of Wheatstone bridge, and the four arms of the bridge are what? Now come to the four arms. What are the four arms of the bridge? I can see here the four arms are AD, okay, then DC, then CB, then AB. Okay, these are the four arms of the bridge. These 4 arms containing 4 resistor R1, R2, R3, R4. And here, see, here is a detector is given. You can also call it a galvanometer or a null detector. We actually call it as. Okay. And moreover, you see here, current is passing through it. That is I1 is passing through, R1. So I1, I2, I3, I4, 4 currents are passing through all the 4 resistors. Now, when the current through the galvanometer is 0, okay, that is suppose at the time, you can see galvanometer is situated between D and B, okay. So we can say when the current through the galvanometer is 0, so at the time the terminals B and D are said to be at same potential with respect to the point A, okay. So this thing is very important, that when the current through galvanometer is 0, so we can say that the terminals B and D, okay, are said to be at same potential with respect to the point A. So in this condition, we can write what's the formula we can write if you are trying to validate this statement. Under this condition, we can write that VAD, this is the arm AD, is equal to VAB, because I'm telling that terminal D and B are at same potential with respect to point A. So this condition is valid under this condition. That's why they have written under this condition. What is the condition? That no current is flowing through galvanometer, means no potential difference across the galvanometer, means they have same potential. That means they have a balanced condition, okay. And that means this balanced condition is between the terminals D and B, okay, with respect to A. So we can write this formula, this condition, we can write that VAD is equals to VAB, okay. Just follow the arms. See, I have give the name of the arms like this, A, B, C, D. You can also change the thing. It's not required that whatever I have given the naming of the arms, you have to follow that. Okay, just follow the process. Okay, so naming it can be done by you by your own. Now you see one more thing, that if I write here that the voltage across or potential across AD is equal to AB, then I also know that what current is flowing through AD and AB. So if you check it out, you can see here what is the current and what is the resistances there in case of AD and AB. So just to check it out, you see here the current across AD is flowing, that is I1, isn't it? I1 is flowing, and as it is a balanced condition, or you can say this is called a balance of the bridge. So what we know, we also know that I1 is equal to I3 and I2 is equal to I4. That means under this condition, as we have written, if we can write VAD is equal to VAB, again we can also write that VDC is equal to VCB, right? Because the detector is, galvanometer is in the middle. So whatever will happen, it will be in common to both the sides, to both the side of the arms. So if we can write this equation, we can also write this equation, that is VDC is equal to VBC. Okay. Now, if this thing happens, what actually conclusion we come that I1 is equal to I1 is equal to I3, because I'm talking about a balanced bridge. Okay. And another thing is that I2 is equal to I4. Okay. So this is the balanced condition I can obtain from the bridge from these equations. And if this happens, we also know resistance will be also equal. That means R1 is equal to R2 and R3 is equal to R4. Okay. This is the balanced condition. Now, one more thing you see here, we can also write that as I have written here, I1 R1 equal to I2 R2. So I think this condition you have no issues to understand. Amisha is joining now. Okay. So I hope this total equations are you have understood why we have written VAD equal to VAB, VDC equal to VBC, and this formulas. Okay. Now you see here we have written that where I1, I2, I3 are the current in resistance, and I have told you I1 is equal to I3, I2 is equal to I4. Okay, so respect to that, we can also write that R1 is equal to R2, and don't mix it up. You can see that which resistances are equal to each other. Now, another thing, R1 by R3 is equal to R2 by R4. You know that I have told that R1 is equal to R2, R3 is equal to R4. So we can also write in this form. And from here, we can write equation also up to this, that because here R4 is the unknown resistance. So we can write Rx equal to R4. I mean, suppose from this equation, if you know other three parameters of resistance, you can find the fourth one, whatever, maybe it's R4, maybe it's R3, anything. Means if you are much aware of this particular equation, then you are able to find out rest of the three. Suppose R1 is not given, you know the values of R2, R3, R4, so you can easily find out the value of R1. So depending upon this equation, we have derived this yellow colored equation, what I have written here, Rx equal to R4 equal to, this is because I have taken R4, because here in this particular condition, I have taken R4 as the unknown resistance. Okay, so I think I could make you able to understand about this. Now, another thing is there, suppose this condition I have written, right? I1 R1 equals to I2 R2. Then you tell me, you again know that I1 is equals to I1 equal to I3. Right, I1 is equal to I3. So if I1 is equal to I3, then what is the equation we can write in terms of voltage? Can you tell me? In terms of voltage, what the equation we can write? Suppose I'm letting here come here. I'm writing I1 R1 equal to I2 R2, right? According to the balancing condition of these two terminals. Now I know that I1 is equals to I3. Okay, I1 equals to I3. So if I1 is equal to I3, then I can write like this, I1 equal to I3 V, that is my supply, divided by R1 plus R3 at this condition. Wait. Can I write this equation from that? Because this is the balance condition and I know I1 equal to I3. So I can rewrite this equation. Similar wise, for IT equal to I4, if I say, suppose for I2 is equal to I4, what is the equation I can write? Tell me. For IT equal to I4, what is the equation we can write in terms of voltage? Yes, Pooja?
V by R2 plus R4.
Yes, V by R2 plus R4. Because I'm telling you this equation, you require, if we try to prove Wheatstone bridge, R2 plus R4. Okay. So this is the thing we are writing. Now you do one thing. Achha, wait. Now you do one thing. You equate the equations. I mean, you substitute the value of I1 and I2. Okay. From the equations 3 and 4 in equation 2, I mean, if I have taken this as equation, wait, this as equation 1, okay, this as equation 2, and what you now do, you just put, you know the value of I1, you know the value of I2, right? You just put the values in this particular equation 2 and tell me the value what you can get. Tell me the value what you can get. Suppose if I, let me share now my whiteboard with you once. So you know this equation, I1 R1 is equals to I2 R2. And just now I told you the value of I1 and I2 in terms of voltage, right? So what you will do, you will put the values V by R1 plus R3, okay? R3, R1, it will be equal to what? V by R2 plus R4, okay, into R2. Clear up to this? You just do the equalization and the formula, whatever. V will be cut because this is common. So you are getting what? R1 upon R1 plus R3, okay, that will be equal to R2 divided by R2 plus R4. This kind of equation you are getting, I hope so. right? So now you will equate or you will cross multiply both the side. Then what we can get? I can see I can get R1 in bracket. I can write R2 plus R4. Okay, and here at the opposite on the right hand side I can write R2 in bracket. I can write R1 plus R3. So this is the equation I think I'm getting. And if you simplify this equation, what you will get? What you will get? You will get R1, R4 equals to R2, R3. Okay. So this you see, this equation we can obtain from the previous equations too. So this is why we are doing. So this equation, if I say the equation number in equation, so I can say clearly that this equation is a very balanced equation, from where I can say that I can find any unknown thing. So if this equation is a balanced condition of the bridge, so and if suppose in this equation, if any of the parameter is unknown, suppose if R4 I'm telling, so its resistance can be measured. Okay. So what if suppose I say I don't know the value of R4. Okay. So how can I write the value of R4? So I can replace R4 with any X or any other term. So the equation I can have R4 is equals to obviously R2, R3 by R1. So this is the way how you can find out the unknown resistance from Wheatstone bridge. Okay, so I hope I could make you understand what is the how you are substituting the formulas and all. So here R3 is a standard arm. Okay, so keep in your mind in this particular equation, if you say R3 is the standard arm and R2 and R1 are the ratio arms. Okay, these are two terms which are used in Wheatstone bridge, that R3 is the standard arm, STANDARD, STANDARD. Okay, this is for R3 I'm using, and for R2 and R1 I can say these are ratio arms. Okay, these are ratio arms. Now, definitely there are some limitations of Wheatstone bridge. Okay, so I'm moving on to that, my slide which I'm having. Example is also given here. That is example of some examples are given. If you I will give you, you can try this at your home to find out the, this is you can say we can use apply Wheatstone bridge in all these conditions, whenever there are equal resistance, whenever there are proportional resistance, as well as whenever there are some unbalanced resistance. So in every condition, these are the actually examples to show you that which condition of resistance we can use Wheatstone bridges. Okay, so equal resistance, see here all the resistance I have taken are equal, or all are 1 ohm. Okay, so two examples I have given you for proportion resistance. In case one case the other two are much less ohm, and here in say it's one is 10, one is 1, so it's different here. So and this is for 2-volt unbalance, means 1 is 2, other two hand is 10 and 1 is 1. So in all these combinations we are able to use Wheatstone bridge. Okay, so these figures are to make you understand that portion. Now, as I told you that Wheatstone bridge is having some limitations. Okay, out of this we need to first of all find out the limiting error of the known resistor. See, resistance we can find out from this particular formula as I told you, but there is another point is to find out the limiting error of the known resistor. Actually many problems come out from this particular equation. Actually this limiting error, to find out limiting error of the known resistors, this condition when it arises, when first is definitely in case of measurement of Wheatstone bridge, some errors are there. Okay, first is limiting error, second is insufficient sensitivity of detector. You can see here detector, it may have some sensitivity issues that comes. Third is change in resistance of the bridge arm due to heating effect or temperature I²R heating effect. Fourth is thermal EMF or contact potential in the bridge circuit, and fifth is error due to lead connection. So all these are the errors which come under the measurement of the Wheatstone bridge. Okay, so this particular formula is very important because many problems come under this formula. Now, this 3, 4, 5, these 3 points, they play an important role in measurement of low value resistance. All these 3 points. Okay, so these 3 points are important in that wise, and this equation is important because we have some problems. See here, one problem is 2, 3 problems I have sorted out. This I will make you do in my next class. So here are some of the problems on the basis of that limiting error, that after applying the error equation, how we can find out. Okay, so this we will do later on. But before that, some of the major sources of errors we need to learn on Wheatstone bridge. Okay, first, as I told you, this is a very important error. This one, insufficient sensitivity of detector, a very, very common. Heating issues, I told you, heating effects on the 4 arms of resistors. These 4 arms, they have these 4 arms, R1, R2, R3, and R4. Okay, these 4 arms, they always have some issues of heating issues. Okay, thermal EMF, very important point. This number 4 point is also important. Now, under leads and contact, the last point, as I told you, error due to lead and contact. So what happened here? Resistance drops, okay, in the wires or contacts, which are used in external bridge circuit. Suppose this is the wire we are using, this green color wire. So if resistance drop in this wire, definitely they will create some error in the in this particular bridge. So that affects the balance of the bridge. Okay, so this error can be used using a Kelvin bridge. Now see, we use Wheatstone bridge. There are many advantages of Wheatstone bridge. Why we are going for Kelvin? Definitely Wheatstone bridge is having some errors, some limitations. That is why we had to move some advanced bridge, right? So see here, this 3, 4, 5, this 3 points, this can be compensated by using Kelvin bridge. Okay, so I'm sharing the QR code once again. You just give the attendance if anybody is left, and the attendance is very less. I don't know why. Understood up to this portion, whatever I've told?
Yes, ma'am.
Okay, thank you so much. I'm again sharing the QR code. So give the QR code, then next class we will continue with the problems of Wheatstone bridge. Okay. Done the QR code. Thank you so much. We will